All right, so rate of change. Um, the concept of a rate of change is really important, and if you can really take hold of this over the next few years, you'll be able to ace calculus and really have a good understanding of science actually too. So rate of change, let's explore it a little bit. Um, and first, I kind of want to review just what is a rate. Um, so we can talk about what's rate of change. It's a rate, some kind of rate. So what's a rate? And to talk about a rate, let's talk about ratios again. So a ratio um, is just a comparison between two numbers. So here's a ratio, 3/4 or 3 to 4. I could write that as 3 to 4, something like that, 3 to 4. That's a ratio. I'm just comparing two quantities, right? Well, a rate is a ratio where the two quantities being compared are in different units. So I could say 3 cookies. Maybe the top quantity will be in cookies, and the bottom will be uh, in hours. So 3 cookies versus 4 hours, and I could actually get the unit right there. Um, you know, 0.75 cookies per hour, something like that, is another way of looking at this ratio, which is a rate. So a rate is a ratio where the units are different. So cookies versus hours. Um, right. So now looking at the slope of a line, I mean, ignore these labels, ignore these numbers for a second. The slope of a line is um, rise over run, or as I like to just say, the change in y, that means change in y over change in x. So if you've got a point going from here, so you've got your line going like this, uh, your rise or your change in y is 1, and your run or your change in x is 2. So for every 2 that you go over, you go up 1, um, basically. So so the slope is a comparison of two quantities, whatever y represents and whatever x represents. So see this kind of similarity here, slope, uh, the rise or the change in y um, over the run, the change in x. So you're comparing something that you're measuring on the y-axis to something else that you're measuring on the x-axis, right? So if I were to graph this situation here where I'm eating 3 cookies in 4 hours, let's say, its slope would just be, 3/4, or meaning as 4 hours go by, as 4 hours go by, you know, I eat 3 cookies, you know, something like that. Um, so the concept of so this would be a rate of change actually, um, and because the quantity cookies is changing versus another quantity. So the rate of change is the same thing as slope, except you need to state your units. Um, so 3 cookies per 4 hours. Um, so where slope, the slope could just be 3/4. It doesn't. The 3 and 4 don't really have to mean anything other than you know y and x, right? So, but when it becomes a rate rather than just a ratio, then you're expressing the units. So the rate of change is um, the the change in one quantity measured in one kind of unit versus the change in another quantity measured in a different kind of unit. So it's really slope and rate of change are really talking about the same thing. They're both ratios, um, but rates of change are specifically with two different quantities or two different types of two different units. The quantities are expressed in different units. Um, so um, so for example, let's look at this first one. And I was going to mention, usually when we're talking about rates of change, that lower quantity which you would graph on the x-axis, is some kind of unit of time. Here I have hours, could be minutes, could be seconds, but it doesn't have to be. Usually it is, but it doesn't have to be. So let's look at some examples of rates of change. So I have this one graphed, and so let me look at the two quantities or two types of things that I'm measuring. I'm measuring miles. Let me switch colors again. I'm measuring miles and I'm measuring hours. So miles are on the y-axis and hours are on the x-axis. So if I were to look at this as slope, I would look at the change in y, the rise, over the run, the change in x. So my rate of change here is going to be, I'm going to be going up or increasing by a certain number of miles versus a certain number of hours. So I have two different units here, miles and hours, and as usual this time unit is on the x-axis. Usually when we're looking at change, we're looking at change over time, because time requires change and change requires time. So so my slope of this line is going to be miles per hour, and that's going to be my rate of change. So let's look at what it actually is. So pulling out a couple of points. I mean, this is kind of like going back to linear equations where you just I need some colors that will stand out. I guess that's okay. Let's pick out that point, and it's not quite exactly right there, but it's close enough. So we'll pick out 2 points. So this point is located at the 3 on the x-axis and 80 on the y-axis. Okay, and then let's look at the other point so we can see how x changes versus how y changes, or how hours change versus how miles change. Or I should say miles versus hours. Miles is on the y-axis, so it'll be the first number in the ratio. Second point is that looking at 5 hours and 130 miles. All right, so the slope here, which will be a rate of change, we can express it as a rate of change. You're expressing the slope as a certain number of miles per a certain number of hours. Two different units here. So what's my change in y? I go from 80 to 130, so that's a difference of 50 miles. The difference of 50 miles going of positive 50 miles. That's going up by 50 miles, and then my time changes from 3 hours to 5 hours. That's a positive change of 2 hours. So I've got 50 miles per 2 hours, and I could reduce that to, let me put that over here, 25 miles per 1 hour, which, as we would say in normal everyday life, 25 miles per hour. So this slope, the steepness of the line, represents speed, velocity, 25 miles per hour. If this line were steeper, I'd be going faster. If it were shallower, I'd be going slower. So the rate of change here is another word for speed in this case. So the rate of change is the change in what you measure on the y-axis versus what you measure on the x-axis. These are the two different units, miles, hours. So 25 miles per 1 hour, and that's our rate of change for this example. Okay, so let's look at a couple of non-graphed examples. In 2002, there were approximately 25,000 bears in northern Minnesota. As of 2010, there were only about 20,000 bears. What is the rate of change of bears per year? So I'm not going to technically graph this, but just kind of give you an example of what the graph might look like if you were to graph it. You could do starting at 2002 and then looking at 2010. So this would be the x-axis. You'd measure the years, the unit of time, Okay, so in 2002 there were 25,000 bears. So let's say that's 25,000. As of 2010, there's 20,000. You know, it's gone down a little bit. So you draw something like that with a negative slope. Um, put B for bears here. So this rate of change would be in bears per year. The bears and years are your two different units, and your rate is going to be a comparison of those two units. And so you'd be comparing how do the bears change versus how does the time change. So okay, so what is that? So let's look at our rise over our run, or the change in y over change in x, or change in bears over change in years. So what's our change in bears? We go from 25,000 to 20,000. So that's a loss of 5,000 bears over that time period. So that's our change in y. Change in y. Doing change in y over change in x. What's our change in years? I'm just gonna write a B for bears. Years would be 8 years, right? So you could reduce that. So the rate of change there would be negative 5,000 bears per 8 years, and should probably reduce it so it makes the most sense. You can just divide 5,000 divided by 8. I'll put a negative sign on it. So that's negative 625 bears per year. So so the rate of change here is a loss of 625 bears per year. So it's 5,000 bears over 8 years, which amounts to 625 bears in 1 year. All right, let's look at one more example. A rocket sits 100 meters above the ground at the moment of liftoff. 4 seconds after launch, it is 1,000 meters above the ground. What is its average rate of change? It's which we would call velocity in this case. So I need some room, don't I? Let me just delete this. Okay, there we go. Now all the bears are gone. Actually, let me delete this. Let me delete this. Okay, so we want to look at how. It's okay. What are we going to measure on the y-axis, and what are we going to measure on the x-axis, just to make it concrete? Actually, let me one more color change. So what's our time variable? Okay. So 4 seconds after launch. So we're gonna measure seconds here, and then meters here, meters above the ground. Okay, so you're kind of at 0 seconds. That's right at the moment of launch, and then 4 seconds later. So right at the beginning, you're 100 meters above the ground, just because of the launch pad being what it is. So you'd be there, and then at 4 seconds later, you're 1,000 meters above the ground. So what's our change in y? Our change in meters. So we went from 100 meters to 1,000 meters. So that's a change of 900 meters. You've gone up 900 meters over what time frame? Over 4 seconds. Right? So 900 meters in 4 seconds. This is kind of sloppy, sorry. So just to turn it into something that's easily understandable, we can just divide to turn that into unit rate. That's 225 meters per second. 225 meters per 1 second. So I just reduced it. 225 meters per second would be the rate of change for this problem. So rate of change, you're looking at a change in some quantity. Here was a distance in meters. Here was distance in miles. The other examples is just number of bears versus some other quantity, usually measured in time, often measured in time. Hours, seconds, years. It could be something else too. So rate of change is the slope. So the change in y over change in x but these things have actual meaningful um, they're meaningful units. I mean, so these are quantities with different units, so not just y and x, but you know, meters versus seconds, something like that. So these different units. So that's what makes it a rate. Um, but if you were to graph it, that would correlate to the slope of the thing that you would graph.